All right, so this is worksheet 4, and we are verifying identities, and they are not tricking us. The side on the left of the equal signs equals the side on the right. And I'm going to do them 2 ways, okay? The first way I'm going to do this is I'm going to not touch one side. That's my goal for you. Leave one side exactly the way it is and show the other side. You can change it into looking like the first side. Now, number 7 is pretty challenging. We're supposed to show those are equal. Now I'm going to show you another way to do it, which I would rather you not do, but it's a little easier if I let you change both sides to show each side, only each one will be equal. So I'm going to do it both ways, but I'm going to show you the hardest way first. So for me, when you do these, the first thing you want to do is change the hardest looking side, the most complex side. So on this first problem, to me, they really don't look that much different. But I think the one on the right is more complex because the denominator has 2 terms. It's a binomial denominator. The one on the right is a monomial, so I think it is less difficult. So what I'm going to do is I'm going to change the one on the right. And I'm going to make it look just like the one on the left without doing anything to the one on the left. Okay. Oh, thank you. So my question to you is, what number can you multiply anything by and it doesn't change its value? 1. So because I know my math really well, I'm going to multiply this side by the conjugate of the denominator. And the reason I'm going to do that is there's 2 reasons. One reason is I need a 1 plus x in the numerator. Do y'all see it over there? I need a 1 plus x. And the other one is these conjugates, when I FOIL those conjugates in the bottom, they give me a difference of the 2 things squared. Okay, I am not going to, because I need 1 plus x in the numerator, I am not going to distribute. I am not distributing the cosine because I need the 1 plus x in the top. That's why I'm not distributing it. I got to have a 1 plus x. If I distribute cosine in there, I no longer have the 1 plus x I need. And when you FOIL conjugates, you get a difference of squared. Well, hey, 1 minus sine squared should make something go off in your brain. What identities? Pythagorean. And if you know these, you already know what that equals for Pythagorean identities. Does anybody know what that equals? It equals cosine squared x. And now I can reduce common factors. Does everybody see I have a cosine x in the numerator and I have 2 of them in the denominator? So I can reduce this to a 1 and that to a 1, which will give me 1 plus sine x over cosine x. What do you notice about this right side compared to this? You see how I just made it look like that? Now, is that easy? Well, no, that's crazy hard, but it looked easy, didn't it? Okay, it looked easy because I know what I'm doing. Now, I'm going to show you something that you're going to be allowed to do, which I don't really care for because I want you to try to do this. This is the harder way to do it, and it's the best way for you to learn your stuff. But the other teachers think it's too hard. So, another thing I can do here is work on both sides at the same time. What's it called when you have what is this kind of number, 1 plus sine over cosine on the left? What's that called? What kind of number is it when you have this line? Fraction. What's on the right side? Fraction. Now let's go back to pre-algebra days. Actually, I know some of you did this in 5th grade because I have a son in 5th grade and he's done these. What's it called when you have a fraction equal to a fraction? Anybody remember? Okay, a ratio is half of it. Like back in the day, it might have said 2 out of 3 doctors recommend, and you could write that as a fraction. That is a ratio. 1 fraction is a ratio. What is it when you have equal ratios? It's got a different name. It starts with a P. R. Close. PROPs, right? Proportion. This is a proportion. How did you learn to solve proportions back in 5th, 6th grade, 7th grade? What did you do with these? Cross multiply, right? And I'm going to tell you, leave the numerators where they are. Because when you have inequalities, if you leave the numerators where you are, it works the same way. In other words, I'm going to take this 1 minus sine times that side, and this cosine over there times that side. So I got 1 plus sine x times 1 minus sine x is supposed to equal cosine squared x. And if you FOIL conjugates, you remember what you get? You get a difference of 2 squares. And what's 1 minus sine squared equal? And you are not done until you show both sides are exactly the same. How many thumbs up on this? Again, I prefer you do it the way I showed you the first time, which is only mess with one side. But if you do both sides, you can, but you're not done. You must show me everything on both sides until you get exactly the same thing on both sides. If you recall, the first time I did it, I got down here to this, where this was exactly the same as what was over here without moving anything over here. So I really showed you that both sides were the same. You understand what I'm telling you? Okay, we're going to go on the back side and do another problem that you guys picked, which is, I think, number something. Number 12 we're going to do. Now, again, you want to start with the most complex side. Can anybody tell me which side is more complex on the equal sign? Totally the left side, totally. So we're going to mess with the left side, okay? I'm supposed to show that it equals secant, let's say squared, I think. All right. I'm going to do what we've been doing the whole time. I'm not going to touch the right side at all. And there's nothing to do to the right side, to be honest with you. So what I'm going to do over here is, guess what I'm going to change everything to? That's right. So I get sine squared x over 1 times 1 over cosine squared x plus sine squared, oh, I put x, sorry, alpha. By the way, that's a Greek letter as well. And if you go far enough in math, or over 1 times 1 over sine squared alpha. You go far enough in math, you'll see that little alpha symbol that kind of looks like a fish. That is also a proportionality symbol in math classes. Science uses it as a proportionality symbol. But anybody here in science, and like physics, you might see this proportionality symbol somewhere in there. All right, so what do you get when you take sine squared alpha over 1 times 1 over cosine squared alpha? What's that equal? Sine squared alpha over cosine squared alpha. And over here, you multiply, or what do you do with this sine squared on top and the sine squared on the bottom? What do they do? They reduce to 1s. So you got 1 times 1 over 1 times 1. What's this whole thing? 1. Anybody know what sine squared over cosine squared equals? Tangent squared plus, oops, I left my alpha off. You got to keep your alpha on there every time. Tangent squared alpha plus 1. Anybody know what tangent squared alpha plus 1 equals? Where would that be in your identities? Okay, look in there. What's tangent squared alpha plus 1 equal? Guess where I just got to? Then I just show the left side becomes the right side. And they're the same. Is there a question on that? Anybody? How many are thumbs up on what you're supposed to do here? Okay, are these challenging? Heck yes. Don't quit. Keep trying. Don't give up. Okay, so right now I'm going to pause my recording.